the date on here. I will give this one back to you. So I found the x-intercept. There's only one, right? I found the local min, the local max, and I put the keystrokes down. So technically, if you want to use this to answer something below, you don't need to do keystrokes again. We don't have to overdo it, right? I just want to make sure you type this in so I know you got it yourself, right? And that's part of the province would require that on an exam. It would require some kind of keys that you press to get there. So here we go. We have a lot of information. I already determined my scale. I go up by 5s, right, on either axis. I have distance in meters, height in meters. That's there, and the scale is there. Okay, so if the scale is wrong, you'd lose a full mark, right? If you didn't label, even if you forgot your units, you lose half a mark. Okay, and so now I'm going to proceed with the graphing part. So the y-intercept is 1617.58, so somewhere in there. And then I have my x-intercept. There's a trick here, right? That you read this part. The equation is only valid for a horizontal distance of 30 meters. So technically the x-intercept is there to guide me, but I really need to figure out, right, when x is equal to second trace 1, when x is equal to 30, what's y going to be? That's going to be my end point there. So I actually didn't do that yet. No, this is not yours, right? This is a different one. This is the one. Here. This is the one. Okay, so I'm going to graph it. Second trace 1. When x equals to 30, y is 2.43. Okay, so this is actually, that's the point that we're going to include here. So 30, 2 point, this is 1, 2, 4, 3 is right about there. So that's where my curve is going to end, not hitting the x-axis, okay? So y-intercept, my endpoint, the local min is at 9.7, 5.82. So I was actually trying to make it, this grid was pretty good for you, right? Like you could actually come up with a decent scale. The max is at 22, 9.95. That's almost 10. Right, so there I have what I need. I come down through the low point, and I make it through the high point, and then you ease your way down to there. So that's the slide. I'm going to make sure the equation is on there. Is this going to work? Plus 17.58. Okay, so the equation, the graph, if you miss this part, if you actually went, we'll take off half a mark, right? If you went past that, if the question tells you exactly, right, then make sure you follow that. So there are your 3 marks, and you're good to go. Now let's answer some questions here. Any part of the slide that is 10 meters or more above the ground must be fully enclosed for safety. How far horizontally must the slide be fully enclosed? Okay, so this is one of those questions that is like, how much time was the ball at or above a certain height? Except for now it's asking you for distance, right? Horizontal distance. So we're going to go ahead and do that. So what you should be doing is, hey, I'm gonna graph the y equals 10 line, and I'm gonna find the intersection of those points, right? So there's 10. That is it. You know what? I'm gonna change my window a little bit. Sorry, guys. That's the downside. One is grade 11 applied calculator, and the other one is grade 12 applied. One is in degrees, one is in radians. So you got to make sure I have that. I make a distinction. Sorry, let's try this again. There we go. I'm going to zoom in a little bit. I'm going to make my Y max a lot smaller. I'm going to go 30. for y max and maybe -10 for y min. That's better. I want it to be maybe closer even. I wasn't very nice there, was I? Anyways, we'll figure it out. So second trace 5. I'll come up with this point right here. So I need that one. So 3.5188 for now, right? 10. And then I'm going to come up with the other one. Let's see if it touches. It doesn't. Did you catch that? It doesn't touch, right? I think I did that on purpose to make you really use your calculator wisely. So all you need to fence in is this stretch right here, right? From the beginning to here, and then nothing is over 10, okay? So all we need to do here is, if you wanted to go -0, you can, but why? It's not necessary. 3.2 meters horizontally. Okay. My guess is I wanted it to cut through here, but I would have to make it lower. Anyways, can we make this out of 1? I think it should only be worth 1 mark if you don't have to subtract anything. That's my bad. How high up the slide? How high up the slide are you 15 meters into this section? That's what that was supposed to say. So, so we're going to go second, trace, value, x is equal to 15, right? And we're going to figure out our y value there. So second trace 1, 15. So we are at 7.46 meters. If you do that, you get the mark there. As long as I have the units there, you're good to go. State the domain and range of this function given the context. Your domain should be fairly simple. It's 0 to 30. Your range, right, you go from 0 distance all the way to 30 where it ends, and the range is your y values, right? So the lowest y value is my min, which I'm going to go get it from here. It's 5, sorry, no. That's the lowest, right? 2.43 is the lowest. Thank you for that. 2.43. And the highest in this case would be your y-intercept. Would you agree? Right? That's the highest. So that's 17.58. Okay. So there, 1 mark for each. 1 mark for each. If you use the interval notation, right? Sure, go ahead. And then you've got to use distance like this, squiggly brackets. And then it's 2.43. And this would be h, 17.58 like that. Either one is fine. Write an equation that would result in a slide with a higher launching point. Higher launching point. So we go h minus 0.00. You basically want to copy everything else to be safe, right? Minus 2 point, and I will show you what I just figured out. You might think it's not that impressive, but I'm going to make this 27, maybe 27.58, right? Something along the d value has to be greater than the one before. If you were with me in grade 11 applied, you will know what I'm doing right now. If not, you're going to be a little bit lost, but I'm going to show you this later. If you want to copy the first equation into the second, I don't know if you remember this, but remember vars, y vars function, you copy y1, and let's say I want to make this one 10 meters higher, the launching point. I can just take, hey, take y1 and just add 10, and then graph it. There it is. You're not impressed, are you? That's okay. Right? So that's the higher launching point, right? If you make it 10 higher. So it's basically you're adding 10 to the answer. Instead of 17.58, it's 27.58 or whatever. It could be, honestly, if you went 17.59, you get the marks because it's a higher launch point, right? So that's a one marker there for you. So let's see how much we've got here. 1, 2, 3, 4, 5, and the 3, so that would be 8. Notice that the top is actually out of 8, so I bet you I changed B to B out of 1, but I never, right? 3, 4, 5, 6, 7, 8. Yeah, so this page is out of 8. And then the back side, the fun part. You should be good at it by now. Degree of 1, y-intercept of 5, negative leading coefficient. So we go 1, 2, 3, 4, 5 there. I'm going to make it go through there. And this is a linear and has a negative leading coefficient. So you can make it super steep. You can make it flatter. It's up to you, right? That is the equation right there for A. Okay. B is a constant, has a y-intercept of -2. So you just quickly just do one of these. This is -2 and it goes right through there and it's a horizontal line, right? Emphasis on that -2 there. Okay, this is emphasis on the 5 there. One mark for each one of those. And then C, degree of 3. So that's a cubic. 3 x-intercepts, positive leading coefficient. So it has to go up from left to right. And notice this, guys. If it has no turns, there's only 1 x-intercept. So a cubic can have 0 or 2 turns. That's the only 2 options you have. So it must have 2. So I will do one like this, maybe, right? So I'll go through the first one. It will bend, and then bend again, and that's what it's supposed to look like. Something like this, okay? It can have variations, I know. Today you're the judge, okay? You judge your own creation there. Degree of 2, y is greater than or equal to -4. So it, 1, 2, 3, 4, somewhere in here, and the leading coefficient is positive and it's a quadratic, right? So emphasis on the -4 here. It has to be your vertex, right? Because the vertex is the lowest point, and then it goes up. So one mark each. So this is 4, 8, 4, 12, right? 8 and 4, 12. And you put the date on there so that, you know, if you want to go back and look at it,